we're told this is a graph of a derivative. So that means this isn't the original function. This is just all the individual tangent slopes. So this part of the derivative is saying that we have a positive slope of about 1, which means the original graph is increasing. Here we have a positive slope, so the original graph is increasing. Here we also have another positive slope. So even though this hit a max, that's just the maximum rate of increase. It's still increasing. The original f of x is still increasing at x equals 1. Okay. So if I was to make a guess at what the original f of x would look like between x equals -2 and x equals -1, I might say it's something like this. It should level off when we get to x is -1. Because once we get to x is -1, then we're neither increasing nor decreasing. The slope is 0. And then if we get halfway between -1 and -7, then -1/2, right here, we have a negative slope. So that means the graph should be decreasing. So this is one possibility for what the graph could look like. It's still decreasing until we get to 0. And then it starts increasing until we get to 1, then it starts decreasing. But it doesn't have to happen right here. It could be a totally different place on the y-axis. It could look like this. See, there's an infinite amount of different graphs for how this could look. So, when you look at a derivative, you've got to remember you're never going to be able to get the original function from it. All you can do is get some certain information about what's happening with the extreme values. From -2 to -1.5, we're increasing. We're still increasing over here, even though it's starting to go down. It's just the rate of increase has slowed down. So when we hit x is -1, we have a slope of 0. So then that means we've hit that peak that I just drew. Now we start decreasing. So from -2 to -1, we're increasing. We have positive slopes. And then once we hit x equals -1, then the slopes are negative because the graph of our derivative is negative. Then once we hit 0, then we get some positive slopes until we get to x is 1, and then we start going down because the graph of the derivative is negative. So we can say that at x equals -1.5, we've hit a maximum. What is the least value at x for which f has a local maximum? -1, not this part. -1 is the local maximum, because that's where we stop increasing and we start decreasing. So -1. This is also a local maximum too, because you are increasing to the left. Here, I'll make another video with another one. There's a more succinct way we can do this too. Now that I've drawn it out in a not quick math way, let me do another problem in a quicker way. So this is another graph of a derivative. What we can quickly say is that when your derivative goes from positive to negative, reading it from left to right, then you've hit a local max. Because look, all these y values are telling us that the graph is increasing. The graph is still increasing here of the original function because they're positive y values. So we were increasing, and then once we hit x equals 0, then we switch from positive to negative. So this is a local max. Where do we have a local min, though, for this problem? We have negative slopes, and then we switch to positive. So mins happen when you go from negative slopes to positive slopes. So when the derivative goes from negative to positive when reading left to right, then you've hit a local min. And then so we have another place. These derivatives are negative. These are all negative values. And then they're positive. Okay? So we switch from negative to positive, reading it from left to right. That's also a place where there's a local min.